An arithmetic series is when we take a arithmetic sequence and add the terms of the sequence together. And this is called a series. And series is actually quite important in mathematics when we start looking at things in calculus. So this arithmetic series is just one type of series. And we're going to look at a problem here. So James, he's a financial consultant. He has two contracts that he can choose from for his salary. One contract starts at $400 a month and he gets a $100 raise each month for 3 months. And the second contract is he starts with $100 a week, which is fairly equivalent, and he gets a $5 raise each week for 12 weeks. So which contract pays more? So 3 months and 12 weeks, they're both the same time. So contract 1 is fairly easy to do. We have 400, 500, and 600. He does that for 3 months. We can sum those up. That's pretty easy. We end up with $1,500. For contract 2, it's a little bit harder because we're going to have to add up more terms. There's 12 terms of this sequence, and so there's 12 terms of this series. So is there a fast way to add up this sequence? Instead of having to, type it of 12 terms in my calculator, maybe there is a pattern. In fact, there is. When we look at the first term and the last term, the sum of the first term and the last term happens to be 255. If we take a look at the second term and the second to last term and add those up, we end up with 255. And in fact, if we keep doing that and putting it into pairs, because on this side we're taking away 5 and this side we're adding 5, we're just going to keep on adding up the same number. We're going to add up to 255 each time. And what we can then do is, instead of adding these all up individually, 12 terms individually, what we can say is we have 6 pairs of 255, and then we'll say that, okay, well, 6 pairs of 255, when we multiply that together, get my calculator out here, so 6 times 255 gives me $1,530. So it's slightly more, this contract is slightly more than the previous contract. Now the idea then is, what are we doing? We are summing up a sequence. And to sum up a sequence, we want to maybe have a quick way of doing it, and really we want a formula to do this. So to generate our formula for this, we're going to do it this way. So I'm going to take the sum of the 12 terms, and I'm going to write it out from smallest to largest. And I'm going to take that same sum and write it out from largest to smallest. And when I do that, what happens is the two terms here, the biggest and smallest, line up, and I can add those together. And I get a sum of 255 plus, this becomes a sum of 255 plus ... These are all going to be sums of 255. And we have 12 sums of 255. So I get 12 times 255. If I want to find the sum of the 12 terms, I'm going to divide both sides by 2. So I end up with our 6 times 255, which is the same as what I did when I paired it like this. And I end up with 1530. Okay, so that I have this sum where I add the first and last terms. That's going to give me the number, this sum, first and last. If I multiply it by the number of terms, I have double what I really wanted. So I divide that by 2. And again, I can come up with the conclusion here that the contract 2 must pay more. So make note of what happened here. I paired up first and last, last and first, and everything in between really is just the same sum as my first, which I'll call A, and my last term, it gives me a consistent sum of 255. So I must be able to use that sum of the first and last in some way to be able to generate a quicker way to calculate this. In other words, I'm going to come up with a formula.